Welcome. In this explainer, we are going to break down 3 core physics principles that are absolutely crucial for your architectural exams. We're talking about the invisible forces, air and pressure, that honestly, every architect needs to master.
So let's start with this question because it gets right to the heart of how buildings really interact with the world around them. And note that feeling is not just in your head. It's physics on a massive scale. And by the end of this, you are going to know exactly why that happens.
To understand any of these forces, we have to start at the beginning, with the foundational concept. And for that, we have to go way back to 1738, to a brilliant Swiss mathematician named Daniel Bernoulli. This is really the bedrock for everything else we're going to cover.
Okay, this right here, this is the secret code. It's this fundamental relationship between the speed of a fluid, and you have to remember, for us as architects, air is a fluid, and its pressure. As one goes up, the other has to come down. It's an inverse relationship.
Let's really dive into this. Look, if you take away only one single thing from this whole first section, please make it this. This is the golden rule. Write it down. Faster moving air exerts less pressure. It sounds so simple, but it has massive implications for building design, and trust me, it will pop up on your exams. What's so cool about this is that you've probably felt this principle in real life without even thinking about it. Picture it. You're passing a big semi-truck. The air that's squeezed into that narrow channel between your car and the truck has to speed up. And what did we just learn? Faster air means lower pressure. So, the normal higher pressure on the other side of your car literally pushes you towards the truck. It's a perfect real-world demo of Bernoulli's principle in action.
Okay, so how does this translate to your ARE exams, especially for PPD and PDD? Well, this principle is the entire reason we have to calculate wind loads. When wind zips over a curved roof, it accelerates, creates lower pressure, and that's lift. Your structure has to be designed to resist being pulled upwards. Understanding this is key for structural questions, and it's also the scientific basis for a lot of the passive, wind-driven ventilation strategies you'll see on the PPD exam.
So now that we have that basic rule down pat, let's see what happens when architects get clever and decide to use it intentionally. What if we design a space specifically to play with this whole speed and pressure relationship? Well, that brings us right to our next big concept, the Venturi effect. This was named after an Italian physicist, Giovanni Battista Venturi. And it's important to know this isn't some new principle of physics. It's a specific and incredibly useful application of Bernoulli's rule. We're not just watching the effect happen, we are purposefully creating it by designing a constriction, a squeeze.
And this diagram just illustrates it beautifully. Okay, look here. You've got air flowing from left to right. As it gets to that narrow section, we call that the throat, it's forced to speed up. It has no choice. And according to our golden rule, that big increase in speed creates a huge drop in pressure. It's so powerful, in fact, that it can actually create suction, strong enough to pull that liquid up from the tube below.
So, for us, as architects, here's the magic trick. We can design this effect right into our buildings. By carefully shaping openings and hallways, we can create these natural vacuums that literally pull fresh air through a space. It's how we can boost ventilation passively, without a single mechanical fan. All right, let's totally shift gears now. We're going to look at a really powerful building scale force that works a little differently, but is just as important for your exams. This is the force, by the way, that can make those skyscraper doors feel so heavy. Now, this is the key difference you absolutely have to remember. Bernoulli and Venturi, they are all about wind speed. The stack effect, which you'll also hear called the chimney effect, is driven by something completely different, a difference in temperature. And that temperature difference creates a difference in air density and buoyancy. Think of it this way. On a cold day, the air inside a tall building is nice and warm. That warm air is less dense and more buoyant than the cold, heavy air outside. So just like a hot air balloon, it wants to rise. As all that warm air rises and escapes out of any openings near the top of the building, it creates a negative pressure at the bottom, which then sucks the cold air in. The entire building is acting like one giant chimney. And this is a critical two-sided coin for architects. On one hand, the stack effect is this amazing engine for passive cooling, a huge topic for your PPD exam. But on the other hand, it is a terrifyingly efficient way to spread smoke and fire up through a high-rise. And that makes it a major life safety concept for your PPD exam. Controlling this effect in stairwells and elevator shafts is absolutely non-negotiable. All right, let's bring all 3 of these concepts home. We've talked theory, we've talked real-world examples, and we've talked about the pros and cons for us as architects. This next chart is designed to be your perfect summary. the key takeaways you really want to have locked in for exam day.
Think of this as your blueprint for the ARE. For each one, you have to know the key idea, what drives it, and how we use it, both the good and the bad. So Bernoulli gives us the why behind wind loads. That's your PDD exam. The Venturi effect is our design tool for creating passive ventilation. That's PPD. And the stack effect is that double-edged sword. A brilliant engine for cooling, but a critical life safety hazard we have to control on a fire.
So the final thought I really want to leave you with is this. These aren't just some abstract physics concepts you have to memorize for a test. They are timeless, invisible tools that great architecture has used for centuries to breathe. Understanding them isn't just about passing an exam, it's about mastering your craft. Now go ace those tests.